Welcome everybody to LIGENTEC's presentation in this Photonics Plus event. In the next 7 to 10 minutes, I will tell you about LIGENTEC's offering of silicon nitride, versatile low-loss photonic integrated circuit platform. We are a low-loss photonic integrated circuit provider in Switzerland. If you look at a common silicon photonics platform, they are used in datacom and telecom, and especially at 1550 and 1310 nanometers of wavelengths. However, there is much more applications that are covering a much broader range of wavelength ranges where silicon photonics cannot cover all these wavelength ranges. Here, silicon nitride is a material that covers the wavelength range from the visible 400 nanometers up to even 4 micron of wavelength. The benefits of silicon nitride, it's its large transparency window. Compared to silicon, you can go much further down in the blue. It has very, very low propagation losses, observed down to 0.05 dB per centimeters. That is in reference to silicon, where we're talking more about 1 dB per centimeter, and it can support very high power in the waveguide. Here, tested power is more than 5 watts in a waveguide that has a cross section of less than 1 micrometer square. And it is a non-exotic material that is scalable to volume. These benefits of silicon nitride are required for many existing and new coming applications that we're seeing in the last few years. What we propose is to have silicon nitride as a versatile platform to build on. There is offering of 3 different thicknesses: 800 nanometer, 400 nanometer, and 150 nanometers. But you can also have a custom thickness in a dedicated run. There is more than 10 process modules that with that you can integrate your design in a photonic integrated circuit. And we have the extensive process design kit, a PDK, where we cover everything from design rules to design rule checks through building blocks and layout files with an extensive component list and optical I/O improvements for fiber coupling with SMF28 fibers and spot size converters. This extensive PDK is available in a broad range of software providers that is listed here, that help you in either design, layout, and system level integration of your idea of a photonic integrated circuit. How do we see that versatile action of silicon nitride? We see silicon nitride as a base platform that has all these advantages that I mentioned before, and have a heterogeneous integration on top of this standard low loss platform with active components such as lithium niobate, indium phosphide, or other materials. In such a way, we have already demonstrated the integration of lithium niobate and indium phosphide and other 3,5 chiplets, die chiplets, to, for example, get second harmonic generation in lithium niobate, lasers and detectors on in 3,5 materials on the silicon nitride platform. We have demonstrated a broad range of use cases that range from phase arrays that are used for LiDAR, lithium niobate integration with second harmonic generation, frequency comms for metrology and stabilization of a laser down to the hertz level, quantum computing where the quantum states are generated on a LIGENTEC chip through squeezing, polarization management in our platform, AWGs for multiplexing and demultiplexing with very good thermal stabilities, as silicon nitride has a dN over dt stability that is 10 times better than silicon, and photonic photodetector integration. How can you work with LIGENTEC? If you have an idea, if you have a concept, contact us, contact our application engineering, and we discuss the feasibility of your project with that. We have a concept and design study services, and then can go to prototyping either through MPW runs, where we offer 4 times a year 2 thicknesses in an MPW run with process flexibility, device characterization, and packaging, or you can go to pilot and volume fabrication after the prototyping or already starting in a dedicated run, where we offer niche quantities up to large volumes and have the high capacity wafer fab and fully automated testing. With that, I think I gave you a good overview of the possibilities of low loss silicon nitride. We have the basics with a high mode confinement, a light that gives you the ability to have a very low loss, to have the light guided very well, so you can have a very small footprint. You can have ring resonators with a bend radius of a few tens of microns. You have very compact AWGs, and you can put very much power in these waveguides. In addition to that, we offer active integration through either thermal tuning or heterogeneous integration through modulators, lasers, and detectors. You have access through to a full creativity suite of process design kit, where we offer couplers, MUX and DMUX, Mach senders and delay lines, resonators, and polarization control that is implemented in state-of-the-art software houses. And last but not least, we offer the world connections that we know coupling is important. We have optimized spot size converters to couple efficiently light in and out of the chip, have bond pads and cladding openings for sensing. Thank you very much for your time, and please visit our booth in this Photonics Plus conference, where our team is there to answer your questions.